This video is primarily focused on two-dimensional vectors. In statics, you're going to be working hundreds of problems with many hundreds of vectors as part of the problem. The vectors are going to be given in a number of different formats: polar, Cartesian, and others. And so learning vectors well, learning how to do them on your calculator is super important. This is a handout that's on the OneDrive or that's on the course webpage that talks about two-dimensional vector formats and three-dimensional vector formats. In the next several videos, we're going to be talking about 2D vectors and 2D formats. But then we're going to talk about 3D vectors and 3D example problems. And you must get really, really good at these guys and just dealing with vectors on all of these different formats. So again, in this video, we're going to focus on 2D for now. And so the main formats that are used in 2D are Cartesian, where you're basically given an fx and an fy. And again, I'll show you later on the video, on the calculator, in some example problems. But basically, you just go control. Basically, you go turn on. You basically just go control square bracket 50 in the x direction, comma 30 in the y, enter. And that gives you an xy vector. Many times you've got a vector that's given as a magnitude at an angle. And so let's say 50 pounds at 30 degrees. And so you just go control square bracket 50 pounds, comma, you need an angle symbol. So you basically go control symbol, and you come up with an angle symbol. You say enter and put in 30 degrees, enter. And that's basically polar form. Notice it automatically converted it to rectangular form because my default display mode is rectangular, and I recommend you just leave it as rectangular. But again, that's the default display mode. But the calculator, and I'm talking about the TI nSpire or the TI-89, which I strongly recommend that you get, will allow you to enter the vector in any format that it's given, but it will convert it to the default display mode. And we'll show you more examples of these as well. So that's polar. Slope given. So sometimes it's not uncommon to get a vector given is along a slope. In a lot of construction jobs or highway jobs, they'll talk about a rise over run, like a 5-7 pitch, or a 20-degree slope. a 20% grade. So 20% grade is 20-foot vertical change over 100-foot horizontal distance. And so a rise over a run or a vertical over horizontal is a very common way of expressing a slope in construction terms or building terms. And so you'll see a slope given. And if you're given a slope, the easiest way to, and again, we'll show you some examples of this, but the easiest way to deal with that is, like, let's say this is a 3/4 slope. You can actually go to the unit vector function. So if you hit this catalog and go to U, it takes you to the functions that begin with U, and there's a unit V function. And so you just hit enter and then put in square brackets, so square brackets. And in this case, the 4 is the x, so 4, comma, 3 is the y, 3, enter. And it automatically converts that to a unit vector, which is 0.8 and 0.6. And so again, how that works is, so you have a slope that's given as a 3/4, and it implies that there's a diagonal that has a length of 5. But a unit vector has a length of 1. And so this triangular is similar to this guy. So if you take all three of these sides and divide them by the hypotenuse, which is 5, you basically get 1, 3/5, and 4/5. And of course, 3/5 is 0.6, and 4/5 is 0.8. And so the unit vector, which has a length of 1, so a unit vector, we use a u with a hat of this particular vector, is equal to 4/5, which is 0.8, and 3/5, which is 0.6. And that's the unit vector for that particular vector. And so again, so if you have a vector that's at a 3, 4, 5 slope, and he has a 120-pound vector, then you say f as a vector is equal to 120 times the unit vector, which is 120 times the 0.8, 0.6, and 0.8 times 120 is 96. 0.6 times 120 is 72, and that's pounds. And so, again, giving a force at a slope is a very common vector representation. You get these perfect squares, and so this is a document that's on your OneDrive and also on the course webpage of perfect squares. And so a 3, 4, 5 diagonal is a perfect square. A 5, 12, 13 is common. 7, 24, 25 is less common, but it happens. 8, 15, 17 is another example. The rest of these are less common. You know, they go up to 20, 21, 29, 28, 45, 53. I mean, they get high enough that you don't even recognize them anywhere. But a 3, 4, 5, 5, 12, 13 in this class are pretty common. And, but again, if you're given a slope, any slope. So again, if you have a Cartesian system that looks like this, and you have like a 5 and a 7 slope, and this is 300 newtons. Well, if you take the square of this, 5 squared is 25, 7 squared is 49, 49 plus 25 takes you up to 74. So the diagonal here is the square root of 74. And so if I'm going to write this vector as a vector, that's equal to 300. And you can basically just go 7 over square root of 74 is the x component, and 5 over the square root of 74 is the y component. And so this is the unit vector for this guy, because these are the components which have a length of 1 along that diagonal. And so you can calculate it this way, and you can work with it that way. But again, it's easier with a calculator. You basically can go again, I'm going to use the unit vector function. So I'm going to go catalog, click U, which takes me to the U functions, and unit V is what I'm looking for. So enter unit V. And I'm going to go control square bracket, and I've got 7 in the I, so 7, and then comma, 5 in the J, 5, enter. And that automatically converts that to a unit vector, which is 0.8137. So this is 0.8137 and 0.5812. 0.5812. And then I can take those guys times the magnitude, which is 300, enter. And that gives me this vector in XY coordinates, which is 244.1. So that's equal to 244.1. and then 174.4. And that's the XY coordinates of this guy. And again, if you want to see that guy in polar form, then we'll just go function, P, so polar, enter, enter. And that's 300 at 35.54 degrees. So that's equal to 300 at 35.5 degrees. And that's polar form. So the 5/7 slope gives me the 35.5 degrees. And you can go tangent or inverse tangent of 5/7. So we can go trig, inverse tangent, enter, 5 divided by 7, enter, and we'll get 35.5 degrees. And so that's the slope of the 5/7 slope. And so any slope that you're given, again, the unit v function, so again, the unit v function will give you a unit vector. So back to our handout here. These are our three main vector formats in 2D: Cartesian, polar, slope given. And you should be able to convert back and forth between these. And again, being able to do that on your calculator is super easy and super helpful. So I strongly recommend you being able to do that and learning these formats well.